In this episode, cops and robbers and SCOPs.
The client only needs to wear 6 jumpers, 18 pairs of socks, and wrapped up in a duvet.
Sometimes there is a good reason to use a buffer, but it's quite rare.
Kilowatt is a measure of power.
Quite a debate in the industry at the minute, but it is out there and everyone's moved to it.
Simon, why do you hate buffers?
Warm energy wants to be a hero. It wants to give cool a hug.
They're not completely evil.
Put another 50p in the side of it, Ian. It'll be all right. Hi and welcome back to the award-winning Homeowners Q&A podcast. I'm your host Mars, and today we're all about helping you speak the language of heat pumps. Let's face it, the terminology can be overwhelming, whether it's COPs, SCOPs, delta Ts, or buffer tanks. It's easy to feel like you need a degree in engineering just to understand your system. But don't worry, we've got you covered. Joining us today are 5 brilliant guests who live and breathe this stuff. We've got James Moran from Panasonic, Ian Edgeworth from New Perspective Learning Solutions, Patrick Wheeler from Vito Energy, Simon Wardle from Ultimate Renewable Supplies, and Max Waddingham from Good Energy. Welcome, guys. Before we get started, we'd like to thank our sponsor Panasonic for supporting this episode of the Homeowners Q&A podcast. Panasonic has been at the forefront of renewable heating innovation for decades, and their Aquaria range of air source heat pumps is a great example of that commitment. Designed for efficiency, performance, and comfort, the Aquaria line is built to meet the diverse needs of UK homes, whether you're retrofitting an older property or designing a new, low-energy build from scratch. Panasonic continues to push boundaries in this space, helping homeowners transition to cleaner, more sustainable heating with smart, future-ready technology. A huge thank you to the Panasonic team for making this conversation possible. Right, Patrick, let's get going today. So, coefficient of performance versus SCOP. What's the difference and why are they important?
So the coefficient of performance is how efficient a heat pump is. So for every 1 electricity you put in, how much power or energy, however you want to call it, is coming out. So typically we're aiming a coefficient of performance over the year for something between 3.5 to 4. And then once it's evened out and it's over the whole year, and we're taking all seasons into account, we have our SCOP, which is our seasonal coefficient of performance. And that's the one we really care about. Looking at a real-time coefficient of performance is kind of meaningless, because if you look at it in the summer or on a nice warm day when you're only doing a low temperature flow because it's a shoulder month, it doesn't really matter. We're more bothered about how it evens up over the whole year.
I completely agree with Patrick. When I used to do technical surveys, no doubt within a couple of months of the install being up and running, you would have a client phoning you up and saying, we're expecting an efficiency or a COP of X, and we're only hitting this. Seasonal coefficient of performance is really the key to nailing that max efficiency over the season. It's all about economy. It's all about maxing it. But from a homeowner's point of view, it's about understanding that sitting in front of that controller every day, checking what your COP and your efficiency is a moot point.
Patrick and Ian summed it up really well, but from a homeowner's point of view, who's watching this and a little bit confused between cops and robbers and SCOPs, is just really simple, is ignore COP. It's on the fluffy brochure. It's basically giving him 1 point of the year, which is going to be favourable to that machine, where your SCOP is giving over a whole year. So really simple for homeowners is look at the SCOP and just ignore COP.
And actually, really, we're using it as a very basic metric when really all that matters is the cost of comfort. So COP and SCOP are a very, very basic method that we've been using and sort of chasing when it's a lot of us nerdy guys on Open Energy Monitor. But all that really matters is your house comfortable, if you've got enough hot water for you and your family, and is the affordability of this system meeting what you were told it was going to be when you bought it.
You've got a client or a project where we're maxing a COP of 6, and it's great. How did you achieve it? Well, the client only needs to wear 6 jumpers, 18 pairs of socks, and wrapped up in a duvet. There's a finite line for homeowners between understanding efficiency and what's actually comfortable. If it gets to the stage where you're wearing 8 jackets, then you don't actually need a central heating system, and don't worry about efficiency because we're just wasting our time.
James, one question that we regularly get from homeowners is, because everybody knows about heat pumps and they talk about compressors, what exactly is the compressor in a heat pump and what does it do?
Well, the compressor's like the engine in the car, really. It basically compresses the air that's coming in and transform it into heat. How I put it from my not so technical knowledge to try and relate to homeowners, if you think of a bike pump, you put your thumb on the end of the bike pump, you soon take it off because it creates heat, and that's what it's doing. It's creating the heat in the system, basically.
the one thing that homeowners get told quite a lot is that if the compressor goes bang, that is a very, very expensive piece of kit to replace. And everybody talks about trying to preserve the life of that compressor. What should homeowners be doing to actually extend that life of that compressor?
Definitely an expensive component to fix. The way to kind of keep it ticking over as nicely as possible in terms of wear and tear on it is to start it fewer times. And if it does start, hopefully the system's got a soft start mechanism so it's not bang on full power and it's rolling up. So having a really good install, having that flow temperature as low as possible, therefore the compressor's working less hard than it would otherwise, and making sure, I think we'll cover this in a little bit, but we're reducing the cycling element, so the system's installed in such a way that it starts once or a few times a day and kind of stays on low and slow. As with any kind of mechanical bit of equipment, the less you start it and the easier you run it, the longer it's going to last and the less chance of mechanical failure.
So Ian, what is an inverter-driven compressor?
Just about every modern heat pump on the market now is inverter-driven, which means that we can alternate between AC and DC electricity. What that allows our heat pump components, our main components, to do is act in the same synergy that a high-efficiency gas boiler does, that when the demand starts to reduce, the duty on the compressor starts to modulate down, as opposed to this start-stop that Max spoke about. You will see negativity out there about how much a replacement of component X, etc., but we need to start thinking about reliability. Everyone's already got a compressor in their kitchen, in their fridge. Now, when was the last time you turned your fridge off? When was the last time you serviced your fridge? When was the last time it broke down? These things are extremely reliable. They're not new technology. And if we treat them with the respect that we do any other component, then the lifespan of them should be well within what we're expecting.
Patrick, we've spoken about the short cycling, or Max spoke about the short cycling. What exactly is short cycling?
So short cycling is when the heat pump itself, the proprietary controller or the external controller, for whatever reason, can't get all of the heat away from the heat exchanger. So it ends up turning off and then having to come back on again. So you'll see, if you had it on a graph, you'll see lots of peaks and troughs where it's getting up to temperature, turning off and then coming back on again. Ideally, we want to keep it running for as long as possible. So we want to either give it a control input that makes it come on at a low rate and run for a long amount of time, and or give it enough volume and flow around the system at a low enough temperature that it doesn't turn off. Like we talked about earlier, anything that's mechanical, like a car or a drill, if you're turning it on and off and on and off more often, then it's more likely to fail. So if we can keep it really, really, really low for long periods of time, it'll be much more efficient, cheaper to run, and more reliable.
Yeah, short cycling for homeowners, it's really just to go out and check their machine and see if it's switching on and off all the time. If it's doing that 3 or 4 times an hour, there's something wrong. And that can lead to many things. That could be an oversized machine, because they're zoning the house and just running one room when that heat pump is designed to heat the whole house, and using them third-party controls, which we've done many shows about, which is using on and off switches instead of using the heat pump controller or load compensation controllers to control that heat pump. So from a homeowner's point of view, just go out and spend a couple of hours in the garden. You're going to look like you're going mad looking at a box, but seeing if that's switching on and off.
Third-party controls generally are one of the main culprits for this, other than system design. If you haven't got enough volume in the system, it'll cycle as well. Or like Simon said, with lots of zoning, but third-party controls, especially things a bit like the old Hive, any sort of old Honeywell controller, unless it was open therm, but I don't think any heat pumps are open therm to my knowledge. Certainly no mainstream ones. There are a few controllers now which use either Modbus or API, which can maintain and even make it better for cycle rates. So although I've been a bit of a naysayer on third-party controls, we're actually starting to see some really, really good options on the market now.
James, so Simon mentioned going outside and actually having a look at the unit, whether it's coming on or off. Is there a way that homeowners can actually ascertain, just without actually leaving the house, if it is really, really cold outside, to actually determine whether that system is in fact short cycling?
Yes, on behalf of Panasonic, Mars, just probably an example what we can offer in terms of controls, and Simon's a big advocate of this as well, is the smart cloud. So what that allows for the homeowner, they can see what's going on, they can control the heating system, etc. But what's key is for the installer side. So for whoever's always looking after that system, etc., this can pull up ridiculous amount of 72 parameters on there, and they can look at when this system, like Patrick said, peaks and troughs, what's going on with the system down to every minute if they need to.
Thinking about heat pumps? Then you need the Ultimate Guide to Heat Pumps, our latest book for homeowners. With insights from over 35 industry experts who have a combined experience of over 600 years, they're here to answer every question you have and guide you every step of the way. This book will be the best money you'll ever spend on your heating. Pre-order your copy today and take control of your heat pump with absolute confidence. Link in the description. The other thing that I think confuses a lot of people is that installers say, look, you shouldn't have the on-off stat on the wall, but then we talk about load compensation, and it is actually something that does go up on your wall that actually does regulate your actual comfort levels in that house. So what is load compensation?
Load compensation is a means for the thermostat to look at the temperature in the area that it's kind of taking the reading from. Similar to kind of weather compensation, it's trying to look to ramp up or down or modulate. I think we've covered modulation already, to modulate what that heat pump's doing or control the temperatures coming out of the unit. It's very similar to weather compensation, but instead of looking at the temperature outside, it's looking at the temperature in the area that it's reading from, and it's trying to kind of make that offset between what the unit's delivering and the temperature inside the property where the thermostat is.
So, Patrick, you've got a box on the wall at the moment. We've got a heat miser here. If a homeowner's actually watching this and they're going, well, is that a thermostat? Is that from my load compensation? How can they kind of understand as to what exactly that unit on the wall is doing?
To be load compensation, it would have to directly modulate the output of the heat source, which most thermostats don't. So 3 in 1,000 probably do. The heat miser doesn't. It's just a room thermostat. So it will open and close or actuate something based on an input that it gets from the room. So if it's a heat miser stat, it's probably an underfloor thermostat, and it'll be opening and closing in a non-modulating fashion, usually an actuator that's on your underfloor manifold. Room optimization or load optimization is very rarely as good as weather compensation. So what we would usually use is weather compensation with some kind of load limiting device, which would be a thermostat like that heat miser.
Yeah, the good news is for homeowners, most heat pumps coming out over the next 6 months are coming to, they will have load compensation built into that controller. What we've seen a mix of, if most homeowners with a heat pump now will notice that their controller is locked away in the plant room and out the way of sticky fingers. So that will be working off pure weather compensation and working off outdoor temperatures, where them controllers now, you'll see much common space going where normally their boiler on-off stat or their dial stat would have been. Clavette, and there's some others that Panasonic already have load compensation built into their controller, where them controllers now should be going in your common space. And then what that does, instead of being that on-off switch where your boiler, you do the click-clack and it's on-off, what load compensation do is tries to limit that and match what's being lost through windows and walls. Instead of, it tries not to switch on and off that machine. But like we've got through many times, turning on and off machines is not as bad as it used to be. So there's no better efficiency than a machine being off. We just don't want that switching on and off 4-6 times an hour.
Importantly, there's quite a lot of weather compensation controllers that can take an element of room optimization. So with Viessmann in particular, they've got a great controller, which means you can put in a percentage, I think. I remember how you set it, but you can choose how much influence it wants to get from the room and how much it wants to get from the outside, so you can dial it in really neatly.
So James, just to round off this particular subject, if somebody's watching this and they've just moved into a house or they just had a heat pump installed and they've got a branded thermostat on the wall that's not the same brand as the heat pump, chances are that is then not a load compensated device on the wall. Would that be a fair statement?
Yeah, and I'd be interested to get the other guys' opinion. There's probably a majority of maybe, but there's some that are. So it depends on that independent model, if you like, Mars.
So in your case with Panasonic, would it only be a Panasonic unit on the wall that would actually drive the load compensation for your units?
Yes, we'd encourage you to use the Panasonic controls on your setup to allow for all that functionality, yes.
Patrick, is there any kind of other devices you can think of that wouldn't need to use the manufacturer's own controller?
Well, I can't speak for Panasonic, obviously, but lots of manufacturers, if they've got Modbus input, then there's quite a few devices that are coming out that can do it. So the ADIA that we've talked about before can do it. Havenwise can do it. Homely can do it. Although Havenwise is actually via API, so it's cloud-based rather than having to be physically plugged in. But importantly, all of them are designed for low temperature and heat pumps. So they're there to try and promote long flow at low temperature, rather than third-party controls traditionally that were just on-off. So it's go on, and then it'll see a temperature, get up to the right amount, and then go off. And that's what we want to avoid, but not just in heat pumps, in everything. So I've been fighting against it for a couple of decades in boilers, and now with heat pumps, the impact is so much greater.
Ian, so let's talk a little bit more about modulation. What exactly is modulation in a heat pump, and why is that important?
It's all about demand. So it's only natural that at some point, if your system has been designed, installed, commissioned, and is being operated correctly, that ultimately your house will come up to target temperature. But as it starts to come up to target temperature, what we don't want is the traditional method that we've had, which is a switch on, switch off. We're hitting 21 degrees. The appliance switches off completely. We've already touched on the short cycling side of it, but also that on-off. We're putting more duty on compressors. I used to describe compressors as cats, which is a terrible analogy. They're only born with so many lives. We can only bring them back to life so many times before they actually give up. So what we want to do is we want to ramp back that through the inverter-driven system, where the compressor will actually start to slow down. All the components will work in unison with that as we start to climb toward that target temperature. So we're just creeping in exactly the amount of energy that our house needs. Ultimately, what our design should be is it matches exactly the amount of energy that's being lost, but what needs to go in. And we just want that long run period of our heat pump at a low load.
Max, kilowatt versus kilowatt hour.
Kilowatt is a measure of power. How much are you getting at that particular point in time? And then you put that over a time period. So a kilowatt drawn over an hour is a kilowatt hour, and that's what you will be billed by your utility provider. And in terms of heat pumps, it's kind of exactly the same. It's the kilowatt is what is the output of that device at that particular time. If you use that full capacity over an hour, you would have drawn 10 kilowatt hours, 10 kilowatts over an hour. So your utility provider would charge you 10 times whatever your unit rate is.
Yeah, just a simple one for homeowner, and put it into a car-related situation. A kilowatt is how fast the car is going in speed, and then the kilowatt hour is how far the car's travelled in distance. So if you're using a 2 kilowatt heater and you've left that on for 3 hours, you're going to use 6 kilowatt hours over that period.
Are you thinking about getting a heat pump? Then don't get caught out by a bad installation. Bodge Buster is your essential guide to asking the right questions and spotting red flags before it's too late. Written from real homeowner experience, this book gives you the knowledge to avoid costly mistakes and make informed decisions. Get Bodge Buster today in print or for Kindle, link in the description. In the simplest of terms, can you explain what refrigerant is in a heat pump system and how the refrigeration cycle works?
In simplest terms, yeah, it's basically the vehicle that allows the energy to move from the air into the house. So the thing about refrigerant is boils off at a super low temperature, I think R32, minus 52 degrees. So as long as it's warmer than that outside, you can kind of boil this refrigerant. It goes through the compressor. We've already covered the compressor and a few valves and whatnot. And clues in the name, it's compressing it. It's kind of trying to change the state there and draw energy from that and move that into the water that then goes into your home. The refrigerant is what really does the heavy lifting in that stage, along with the compressor. And it's a sealed system in the heat pump in the monoblock. It's a sealed system in the split as well, but the guys do have to tap into that to install it. The simplest way to explain how that works from a homeowner's perspective, I think James, you had said earlier, the compressor's like putting the thumb over the bike pump and doing that. It's exactly that. It's a fluid that goes through a condenser, compressor, condenser, compressor. It's taking energy on, it's giving energy off. That's how it's kind of moving the energy from the air outside into your home as heat, because the heat pump isn't producing the energy, it's moving it from one place to another. It's pumping it, for lack of a better phrase, from the air that's outside, the ambient temperature, into your home. And it's through that mechanism that they can indeed be more than 100% efficient. They will give you more energy out than you put into it to make that cycle work, basically.
So James, manufacturers have now, or in the process of moving over to R290 as the refrigerant. Could you tell us the benefits of what R290 offers over kind of the previous refrigerants that we've had up until this point?
It can allow the heat pump to get to higher temperatures, potentially higher than a boiler. Not that we want that particularly. Obviously, we're trying to achieve as low as we can to create more efficiency, but it can do that. I think overall it is the global warming potential. So it's as low as 3, whereas R32 is a lot higher. So if for every reason that refrigerant wants to leak into the atmosphere, what damage would that do to the atmosphere? And it's a lot lower than R32. Will that change again? Probably. Refrigerant's man-made, so they're always developing. So yeah, it's quite a debate in the industry at the minute, but it is out there and everyone's moved to it.
Yeah, just from a homeowner's perspective, R290, R32, R2D2, we confuse them to death. R290 is what's in their barbecues at the minute, so it's propane. By the end of next year, all heat pumps will go R290 now, and it's just a different type of gas inside your air source heat pump. So, and it works at high temperatures. But one thing I want to get across is R290, not so much now, was being missold in the first place as this replacement to a boiler and run your system at a higher temperature. For every 1 degree a homeowner wants to dial up that heat pump, it's generally going to cost them 2.5% to 3% in running costs. So I just want homeowners to be aware, all because we've got these high temp heat pumps. Don't go running out and go, I don't need to change none of my radiators or my cylinder. I can put this in and replace, because they'll be taking out a second mortgage to run their house.
Ian, whenever we talk about heat pumps, delta T comes up. What is delta T?
It's a differential in temperature. It's the temperature that I'm sitting currently in my kitchen and looking out my window where it's a bit cooler outside. So, for instance, I have an R290 heat pump that's heating my home right now, even though it's August, but we are in Scotland. So my property just now has got a target temperature of 21 degrees. It's not nice outside, so it's around about 30 degrees outside, I would ascertain. So what we have there is we have an imbalance. We have a difference in temperature between the temperature inside my house and the temperature outside. That's what a delta T is. It's just the difference. So in that instance, our delta T, or our temperature differential, would be 8 degrees from indoors to outdoors. What that means from a homeowner's point of view, and what it means from my point of view right now, is I'm losing energy, because the simple law of thermodynamics, the second rule of thermodynamics, is that warm energy is attracted to cooler energy. Warm energy wants to be a hero. It wants to give cool a hug and bring a balance to the universe. But unfortunately, it's not as simple as that. So the heat inside my home right now is looking out the window and saying, that's a shame. They're only 13 degrees. Come on out and we'll do a group hug. That's a difference in temperature.
Patrick, the most divisive comments when it comes to heat pumps continues to be buffer tanks versus volumizers versus low loss headers. Could you just give us, in the most simplest of terms, a definition and an explanation of what each of those three are?
So a volumizer is the easiest one. It's literally just a bigger bit of pipe to give you more volume to the system, so that it can stop from overheating as quickly, or it can give enough volume for defrost. So just think of it as a bigger pipe. It'll look like a buffer as well, but it's just got one pipe in and one pipe out generally. And then a buffer and a low loss header are basically the same thing, except a low loss header is tiny. And a buffer is very big. And a buffer can be plumbed in many orientations. Some are better than others, but it's essentially there to split up the flow rate from each side. So you've got the system side, your radiators, your underfloor, which are going at one particular flow rate, and then your heat pump, which wants to go at another particular flow rate. And it allows you to have differential flow rates in the system that the heat pump might not otherwise like. Lots of manufacturers quite like this. And I think there's a liability aspect there, because they can say, well, we can see that our heat pump's circulating on our side. We can see that that's heating up. We're giving the right amount of power to your hydraulic separator, your buffer. So it must be a system problem. Generally, and not just with hydraulic separation, but with controls and lots of other things, we should be trying to engineer out anything unless there's a really good reason to use it. Sometimes there is a good reason to use a buffer, but it's quite rare. In most cases, if you're having a heating system fitted, you want to keep asking, why am I paying for that thing? What is it? Why have I got extra pumps? Why have I got extra valves? Why have I got extra controls? Why have I got a buffer? What's the purpose of this thing for me to pay for it and have it there as a long-term liability?
Simon, why do you hate buffers?
I love it. The one thing I do hate is that Mr. and Mrs. Miggins again has to pay the pleasure of anywhere between £400 and £600 to have this thing put in with an extra pump and the buffer, and find the space to put it. Now, the problem over the last 7 years is heat pumps have all got modulating pumps inside them now, and they don't allow for you to control the other side of that buffer. So I call it two Scalextric tracks. You've got the heat pump, which now thinks the buffer is the house, and it will spin around that. And that's why manufacturers do like buffers, because that heat pump will spin around that Scalextric track with nothing in its way. And anything happens over the other side, the manufacturers will turn around and go, well, that's down to the plumber, that's balancing. Go and touch the primary pipe work. Is it coming out at 50 degrees? There's nothing wrong with our heat pump. But poor old Mr. and Mrs. Miggins has either got a cold house or spending a fortune on trying to heat that house. If, for instance, Patrick's got one, I've got one, we've got an ADIA unit inside our house. And really, that is a hydraulic split. But what that very cleverly does, it's got a modulating pump in there that is mirroring the primary side. There's very little, if any, distortion. So really clever bit of kit. So if buffers are all put back in and all the heat pumps could control that second pump after the buffer, there will still be a bit of distortion and less efficiency, but it would work really well. But unfortunately, not many heat pumps can look after that secondary pump. So, but like Patrick said, it all comes back to when you have any kind of hydraulic split, there is always going to be distortion through there. And unfortunately, at the minute, the scenario is with installers that don't know is I call it the broken watch scenario. It's going to be right twice a day. We've got a pump that's moving up and down depending on the load, but we've got a fixed speed pump the other side. So if it's pumping too slow, it's not putting enough heat into that buffer to heat the house. If it's going too quick, we're going to short cycle the heat pump and the heat pump will switch on and off. These can easily be designed out, and you can create a buffer in the house by simply putting a couple of lock shields on radiators or cherry picking some actuators off underfloor heating to create that system volume around the house without spending that extra or charging that customer £600-700 extra on their bill, plus getting less efficiencies. Ofgem done the stats a few years back with all them systems before HeatGeek were around, and all of them systems, I think there was 300,000 systems, and they come out with an average SCOP, first of all, of 2.4 before they were embarrassed by that, brought it back in and put it through the washing machine and come out, oh, wow, 2.6. We all know we have to be roughly 300% above efficiency to be cheaper than that gas boiler. So buffer, no. 99 times out of 100 now with all households, the way they're designed and the way they're run, you do not need a buffer.
Max, Simon mentioned the word distortion. Could you just tell us what distortion is?
We've teed this up already. We spoke a few times, delta T and flow rates and things like that. Simon kind of touched on it there, but it's just the hydraulic separation, and then it creates a difference between what the heat pump's doing and what the system is doing, usually affecting the temperature. You've got something going on the heat pump side. It's coming up to this hydraulic separator, buffer, low loss header. The heat pump's trying to put out 50 degrees, say. The secondary side, the radiator side, is doing its own thing with its own pump speed. It's very hard to match those flow temperatures up and those flow rates where the energy you're putting into that separator is matched by the energy going out. So then you end up having the heat pump usually running a bit hotter because the return's coming back a bit lower than it's expecting to see, and they start to run away from each other and distort what's going on between the heat generator and the heat delivery mechanism, be it underfloor radiators. They're not able to run in sync because you've separated the hydraulics there, and they can't run in tandem.
I used to describe a buffer as a busy hotel kitchen. So you've got the chef who's creating all the energy and coming out with the dishes and putting them on a serving desk. The serving counter is the buffer. He can then return back to that kitchen to get some more energy, bring more food out to the serving counter. Meanwhile, the waiting staff are coming and picking up that energy and going to the tables. The tables are the radiators. So you can have 8 or 9 waiters going cock a hoop round all of these tables, giving out that energy to the people that are hungry, i.e. the rooms, coming back to the serving desk, and both the chef and the waiting staff can move at different speeds. If the chef decides that there's a problem with the freezer and wants to defrost it and take a bit of a break, then the waiting staff can still pick up that energy. When the tables start to get cleared as people finish the meals and the system starts to reduce and the speed starts to reduce, the chef can still move at different speeds. I think from a homeowner's point of view, if you've got a designer stroke installer that is suggesting a buffer as an essential, medium, I would ask for a second opinion and speak to someone else.
Buffers do exist for a reason. People smarter than us have invented them and have put them into schematics. And, we use it in commercial heating. We use it when there are multiple heat sources. So if there's a boiler and a heat pump, we might have it. And we often use it, almost always use it, when there are two heat pumps. So if you've got a cascade of heat pumps, you've got to have some way of consolidating the flow and getting them into one place where you can use it. So they're not completely evil. They do have a place, like everything pretty much. It has a solution, but it's certainly not a panacea, and it shouldn't be used on every job, and it should be questioned. Has it got a reason? What's its purpose? Why am I paying for it?
James, domestic hot water, how does that differ when it comes to heat pump versus kind of your old traditional type heating systems?
A lot of the time when you're having a heat pump fitted, you have a hot water cylinder as well. So almost like a big storage tank, to simplify it. That will be stored at a certain temperature, but with the heat pumps, it prioritises your hot water over your heating. So with the boiler, it does whatever's needed at the time, but the heat pump will always prioritise your hot water. So in terms of that, it's looking for, has it got a demand to heat that tank up to your target temperature? Again, without going back onto Panasonic all the time, but say your target temperature is 55. If that drops down to 47, it will flip back over to hot water because you've got a different rate set up there. So you're not having to heat from 10 degrees all the way up to 55. So that's where you're saving. If you let that drop down all the time, that's where it'll cost a lot more. In terms of usage, well, let's look at how long will that take? You've got a 200 litre cylinder from 10 degrees, 45 minutes. So it is a bit more time. If you've got 3, 4, 5 people using that consistently, bath after bath, shower after shower, it will run out, and you've got to expect a time for that to heat back up. But what the heat pumps are good at these days is learning your behavioural patterns, and the homeowners will learn to do the same. So one showering in the morning, one showering at night, that sort of thing. So what we're finding in terms of designs like through Simon, etc., and the installers, this is all in the design. On the back of that, it's not something you should really worry about, because we're designing it to the property. How many bedrooms has it got? How many bathrooms has it got? How much usage could potentially at its max option, so that you're never in that situation. So it is different from a boiler. It does prioritise your hot water, but the design's right. The installer's done the survey right. You should never be in a situation where you're struggling with hot water.
Yeah, just to add to that, it was just really, as I like to add to everything, your heat pump is just a boiler that now lives outside. So when you ask that question regarding the gas boiler, is it the same? On a system boiler, you'll have a cylinder in the cupboard and boiler in the kitchen wall. Predominantly, though, what we've got in this country is a lot of combis, which you won't find a hot water cylinder in a cupboard. So Heat Geek and us, we've kind of Adam very kindly shared it, but to get over that issue, if a homeowner's got a gas combi and goes, well, I can't have a heat pump because I've got to have a cylinder, we've both come out with what we call a combi stall. It will basically, the heat pump will then do the heating and hot water, but where that boiler was being ripped out, it's just, from a homeowner's point of view, it's a tiny little tank that will go in the place where their boiler was. So they think they can't have a heat pump because they've got a combi. They can have this little combi store, which will go in the place of where their boiler was, heat pump outside, and they'll get their heating and hot water.
Last one to you, Max. So the one thing that a lot of consumers get a little bit concerned about when they start reading up about heat pumps is defrost cycles. What is a defrost cycle?
We covered the refrigeration cycle a little bit earlier. We talked about that giving energy to the property. Sometimes in doing so, it will freeze a lot of the water from outside, the humidity in the air. It will freeze that against the heat pump. So it just needs to give a little bit of energy back, reverse that cycle, kick a few kilowatt hours, because we know what those are now as well. Kick a few kilowatt hours back into the heat pump, just to put that heat into the back of the heat pump there and defrost it, and then reverse itself and kick on again. Generally speaking, you will not notice this is going on at all in your home. There's very little you have to worry about in terms of making your radiators freezing or anything like that. Again, a well-designed system, or even those with a buffer, it's going to take a little bit of energy spread over a big area. You shouldn't notice anything going on. It'll just take care of itself, flick itself back into heating and crack on.
Patrick, how common are defrost cycles, and how long should they last?
Depends how hard it's working and how much volume it's got for defrosting. Might do it a couple of times an hour in the middle of the winter. The only real signs you should see of it, as long as everything's running well, is that you'll have a little puff of vapor coming out of the outdoor unit occasionally, which is a bit of a shock to us the first time I saw it at our office, as it sort of rose up past my office window. But for the most part, the homeowner shouldn't know anything about it, unless there's a problem with design or the system, in which case it might take too long to do it. You lose quite a lot of the potential power input to the house. So you might find the heating goes a bit cold. So we've noticed that with systems that are sized really, really close to the bone or slightly undersized. That's when you're really going to notice it, is when it's trying to do a defrost and it's doing it for 10 minutes or so. You've then got a sixth of your hour that it's not giving you any power into the system. So you'll end up with a slightly colder house than you should do when it's the very depths of winter anyway.
I just want to do a favour for the installers and manufacturers here. So when homeowner has the heat pump for the first time, I have generally a good laugh when I do pick up the phone and hear this is homeowner rings up and thinks the heat pump's on fire or it's got ice building up at the side and the back, and they get straight on the phone. It's completely normal unless that block of ice is going to stay there for a long time. And when that puff of vapor comes off the back, sometimes that be quite immense. So we've had many a phone call, and probably manufacturers do as well, with going, the machine's on fire. No, it's not. It's just going through a defrost cycle. So when it's roughly below 5 degrees outside, they're going to see that quite often, every couple of hours probably. So don't panic. It's completely normal.
If you've got any questions about heat pumps, then you need to join the Renewable Heating Hub forums. You can connect with other homeowners, share experiences, and get advice on heat pumps and renewables. Sign up today and be a part of the conversation. Link in the description. So that wraps up another episode of the Homeowners Q&A. A huge thank you to James, Ian, Patrick, Simon, and Max for translating the jargon into something useful. And a quick thank you to Panasonic, sponsors of this episode, for helping us make these important conversations happen. And if you haven't already, pre-order your copy of The Ultimate Guide to Heat Pumps, our new book that's packed with expert advice and everything you need to make informed, confident decisions about your heat pump journey. Link in the description. Until next time, stay warm, stay green, stay tuned. Goodbye. Ian, we're having a bit of a problem with your device, by the way. It says you're running out of space.
Device storage is running low. You should store and free up device data, but
Put another 50p in the side of it, Ian. It'll be all right.
I can put up with the box because it's over sound's face, so we're all good.
I've realized I speak too quickly. This is the problem. I try and read too fast. My lips can't keep up with my brain.